a little cherry bomb to start off lesson 2 from our review chapter on exponents and radicals. Well, we've had exponents since we've had multiplication, probably as far back as 4th or 5th grade, so super fast review. And I've listed a bunch of properties that you should already remember and should have memorized, but I'll go through this really quickly here and we'll work our way through exponents, scientific notation, just to name a couple of topics. We start off with what the idea of an exponent is for. It's for repeated multiplication. You may remember that x times 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 x is x to the 9th power by counting the number of factors. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factors. X is the base. That's the factor that's being multiplied times itself repeated times. And the exponent tells you how many times it's repeated. So if I drop down to here and I write x times x times x times x times x, that gives me x to the 5th. But x times x times x is x to the 3rd. X times x over here is x squared. My answer is x to the 5th. Notice the 3, the 2, and the 5. That gives us a property. I've listed it here, I've listed it over there. This property says that x to the n times x to the m is equal to x to the n plus m. So with exponents, multiplication becomes addition, which is kind of nice, and we'll talk about that later on again with logarithms. And here's a couple other properties listed over here, but also listed up there. Property that has to do with negative exponents. X to the opposite of n is 1 over x to the n. Of course, x cannot be 0. I forgot to write that down. X cannot be 0. You can't have 0 in the denominator. X to the 0 equals 1 for every number x except for 0. 0 to 0 is an indeterminate form. So if I ask you to simplify just looking at these 3 properties, this is x to the 0. This is 1. We're assuming that x is not equal to 0. So this is 4 times 1, which is 4. Over here, this is 1. 5 to the 0 is 1. This is not negative 5 to the 0. That would be this. This is the opposite of 5 to the 0, so this is the opposite of 1, or negative 1. Using the negative exponent, 3 to the negative 2 is better known to its friends as 1 over 3 to the positive 2, or 1 over 9. Not so bad. Now what happens with the negative exponent in the denominator? Well, here it went from the numerator to the denominator. Here it goes from the denominator to the numerator. This becomes x to the positive 4. This last one, I have 3 factors here. I have a negative 2, I have an a to the 3rd, and I have a b to the negative 7. Think of it as over 1, if that helps you, and this is going to change its place. This is the little shortcut here. I'm going to end up with negative 2a to the 3rd, and b to the negative 7th in the numerator becomes b to the positive 7 in the denominator. Now these properties that are up here are properties that you should have memorized. I used to tell my Algebra 1 students that if you were to get some poster board and write the properties down on the poster board and put them up in your room so that you can see them every day when you wake up, that you would eventually have these memorized. That's how important they are. Now, it's a goofy way to say it, but that's how important they are. Now, I wanted to point out a couple of things that weren't listed here. First off, the quotient of powers. Remember the product. If they have the same base and you're multiplying, you keep the same base, you add the exponents here. If you're dividing, you keep the same base, you subtract the exponents. And here's the little trick with the negative exponent. See how it's up here in the numerator? It ends up in the denominator. Here it's in the denominator, it ends up in the numerator. Now, power to a power is used a lot, and all that is saying is x to the n, m times. You would have x to the n times x to the n times x to the n, m factors of that. And so you'd have m n's, and that would give you the product of the 2 exponents here, x to the n times m. Power of a product, if you have a product of 2 factors that are raised to a power, each factor gets raised to that power. Same thing goes with a quotient. It doesn't work for sums and differences, but it works for products and quotients. If you have a quotient that's raised to a power, the numerator gets raised to the power, the denominator gets raised to the power. Now, if you have a negative exponent out there, that's the same thing as taking the reciprocal to the positive power and then zing right up to there using this property, b to the n over a to the n. And this, of course, is the 0 property. Now, I have 2 kind of complex problems, and I didn't give myself much space here. So I'm going to try to write this out as neatly as I can, and hopefully you'll be able to follow my steps here with my explanation. Time to go purple here if this pen works as good as I think it does. I have 3w to the negative 3 power. The first thing I'm going to do here is write this as 1 over 3w to the positive 3 power. Okay? I'm using my negative exponent property. Over here, I have a product, 3 factors raised to the second power. That means that each one of these gets raised to the second power. The 5 gets raised to the second power, the w gets raised to the second power, and the t to the 5th gets raised to the second power. So here's another product to a power. This is 1 over 3 to the 3rd, w to the 3rd, times 5 to the second power is 25. W to the second power, a power to a power. Where am I at? Power to a power. There it is. Multiply the exponents. This is t to the 10th. Now I'm going to write this as 1 over 27w to the 3rd times 25w to the 2nd t to the 10th all over 1. The 25 and the 27 are the coefficients there of that numerator and that denominator, but no common factors. I do see 2 factors of w here. They cancel with 2 w's of the factor of w here, so that will leave 1 factor of w there. And I end up with 1 times 25 times 1 times t to the 10th is 25t to the 10th. And on the bottom, 27 times w times 1 is 27w. Notice the directions that simplify, only positive exponents, only positive exponents. This one's a little trickier over here because I have more negative exponents. I'm going to take and simplify the fraction inside, the rational expression inside, before I start worrying about trying to cube anything. But I see that negative exponent, so I am going to flip and write the reciprocal and raise that to a positive 3 power. Now, 13 goes into 13 once, 13 goes into 26 twice. This is getting interesting already. So I have a 1 here for a coefficient. I have c to the 1st, d to the negative 2 here. I have c to the 5th, d to the negative 2. I can see 1 factor of c is going to cancel with 1 factor of c down here. It leaves a c to the 4th. And conveniently, d to the negative 2 here and d to the negative 2 here, those are the same exact factors. They cancel out. So I have 1 times 1 times 1 all over 2 times c to the 4th times 1. And that's all being cubed. Well, that means the 1 gets cubed and the 2c to the 4th gets cubed. Well, 1 cubed, of course, is 1. 2c to the 4th being raised to the 3rd power means the 2 gets raised to the 3rd power. 2 to the 3rd is 8. And the c to the 4th gets raised to the 3rd power. And power to a power, you're going to multiply. That's going to be a 12, c to the 12th. Hopefully you can see that okay. It looks like it showed up. And that's how that one simplifies. Notice again, only positive exponents there. We'd have to assume, of course, c is not equal to 0. Okay, here we go with scientific notation. Scientific notation, a number is said to be in scientific notation if it is written in the form a times 10, base 10 number system, a times 10 to the n, where the absolute value of a is between 1 and 10. It can equal 1, but it can't equal 10. And n, this means, remember, n is an element of the integers. Capital Z with the extra slash, looks like a fancy Zorro symbol. That means the set of integers. That's your counting numbers and your opposites. So I have 2 numbers here. Neither one of these numbers is written in scientific notation. They're called standard form. We use scientific notation primarily to rewrite really, really big numbers, really, really small numbers in a nice standard way to manipulate the numbers, as we're going to see, to be able to multiply or divide the numbers. And in this case, I'm going to write 93 million in this form. Excuse me, in this form here, where the absolute value of a, it's going to be positive, is between 1 and 10, including 1 but not 10. Right now, the decimal point is there. I would need the decimal point to be here to make this a number between 1 and 10. So I would have 9.3 with a whole bunch of zeros, which are unnecessary. They're on the end, and they're to the right of the decimal point. So I'm going to write this as 9.3 times 10 to a power. But what is that power? Well, I would have to move the decimal point one place, 2, 3, 4, 5, 6, 7 places. I'd have to multiply this by 7 factors of 10. So this would be to the 7th power. You may recognize this number as the approximate distance between the Earth and the Sun in miles, 93 million miles. Over here, I have 0.000123. The decimal point is here. To make this number between 1 and 10, I would have to slide the decimal point from where it's at here to where it be over here between the 1 and the 2. That way I'd have 1.23. So I'm going to drop all these zeros here, 1.23 times 10 to what power? Well, now I'm not multiplying by 10, I'm dividing by 10. This is going to be a negative exponent. Big numbers, positive exponents. Very small numbers is going to have a negative exponent. I would have to slide it 1, 2, 3, 4 places. This is going to be a negative 4. It's like dividing this number by 10 4 times. So here I'm multiplying, here I'm dividing, here I have a positive exponent, here I have a negative exponent. Let's reverse this. Here's scientific notation. Let's change this into just the standard form of the number. So 4.21, I'm multiplying by 10, 6 factors of it. You know the shortcut, when you multiply by 10, you slide the decimal one place to the right. Well, 4.21, if I'm going to slide it 6 places, I'm going to need some zeros here as placeholders. I'm going to slide it 1, 2, 3, 4, 5, 6, way over here. So I get 4, 2, 1, and 4 zeros. Put some commas in, 4,210,000. Over on this side, I'm going to, let's see, 6 zeros, 7 places. Go again. Thought I had something backwards there. Here we go. This is going to be sliding the decimal not to the right. It's because it's a negative 4, it's going to be like dividing by 10, 4 factors of 10. The decimal point is going to go to the left. But because of the negative here, don't panic, it's just going to be a negative out in front here. And I'm going to put the 1.107, and I'm going to need some zeros here. I'm going to put some extra zeros if I have. And I'm going to slide this 4 places, 1, 2, 3, 4. So I really did put an extra 0 there. The decimal point is going to go right in between these 2 zeros, and I'm going to have negative 0 point, and then 3 zeros, a 1107, and that's what that number becomes. Down here I'm multiplying, and I'm going to use my properties of exponents that we just looked at. I'm multiplying 2 numbers that are written in scientific notation. I'm going to start off by multiplying these numbers out in front. 2.1 times 4 is 8.4, and then I'm going to multiply these 2 numbers here by adding their exponents. So this is times 10, positive 3 and a negative 7 is a negative 4. Now I'm not going to take it any further than that, I'll just leave it in scientific notation. If they wanted me to convert it, then I'd convert it just like I did back here. But in this case, because this number is between 1 and 10, this is scientific notation. If this became bigger than 10 or smaller than 1 when I multiplied, I'd have to make an adjustment. Over here, likewise, I'm going to divide 2 numbers that are in scientific notation. So I'll start off by dividing these numbers here. 8.2 divided by 2 is 4.1. And now I'm going to divide here this number and this number by subtracting the exponents. Negative 3 minus 4 is negative 7, so times 10 to the negative 7th power. It is okay to leave your negative exponents in scientific notation. One last example, a quick application. It says a satellite travels 1.72 times 10 to the 4th miles per hour. That's moving right along. How far does it travel in 24 hours? I went ahead and wrote the 24 in scientific notation. So to multiply and find the distance, we use the fact that distance equals rate times time. So my distance would be 1.72 times 10 to the 4th times my time, or 2.4 times 10 to the 1st power. This is in miles per hour and this is in hours, so the units match up okay. Now I'm going to multiply, and I did not bring my calculator with me, or I just go ahead and use my brain as my calculator and hopefully not make too many mistakes here. That's an 8. That's an 8, carry a 2, that's a 6, that's a 4, that's a 4, carry a 1, that's a 3, that's an 8, that's a 2, that's carry a 1, that's a 1, carry a 1, that's a 4 with 1, 2, 3 decimal places. I like it when it's between 1 and 10, so this becomes 4.128 times 10 to the, add the exponent's 5th power. Now in this case, I want to actually know what this is. This is going to be in miles, by the way, but I want to know what this is in a standard form. I don't want to leave my answer in scientific notation, so I am going to slide my decimal point 5 places, 4.128. I'm going to need at least 2 zeros here to slide it. 1, 2, 3, 4, 5 places. I get 412,800 miles. And that is going to be my answer so that it makes a little bit more sense. Now it is a story problem. It's not a great story problem, but it is a story problem. And in many cases you'll probably be expected to write out your answer so in a short sentence. So you can say the satellite travels 412,800 miles in 24 hours. It doesn't usually take too long to write it out in a sentence, and you don't have to write a paragraph. Just write it so that it kind of answers the question as if you were talking to somebody and you were answering it in sentence form.